Hi, and welcome to this look at a straightforward covalent bonding dot cross diagram exam question. So the first thing that comes up quite a lot prior to having to draw a dot cross diagram is to define what is meant by a covalent bond. Now at A-level, the updated version over and above GCSE is the electrostatic attraction between the nuclei of the bonded atoms and the shared pair of electrons. But the key part of this is still the shared pair of electrons idea, which came from GCSE. So they want you to draw a dot cross diagram for NF3 and BF3. They only want you to show the outer electrons. So the way to approach this is to look at the group that each atom is in. So consulting a periodic table, nitrogen is in group 5, so there'll be 5 electrons in its outer shell. Boron is in group 3, so 3 electrons in its outer shell. And fluorine is in group 7, so 7 electrons in its outer shell. So this will determine how many electrons have to be shared to increase that number of electrons to 8. So you're still trying to meet the criteria you would have come across at GCSE, e.g. 8 electrons in the outer shell when you're doing a dot cross diagram. And the point of the covalent bonding is to share electrons in pairs so that each atom ends up having 8 electrons in its outer shell. So you start off by drawing your circles with a good level of overlap between the circles. Don't forget, you must have the symbol of the element in the middle of the circle to represent which atom it is. So wherever possible, you need to aim to complete the outer shell of 8 electrons. So with this in mind, I normally start with the central atom. So if you put in 5 electrons, in this case I'm obviously making the circles represent the nitrogen electrons. You can see there's 5 of them, and they're arranged into pairs. So there's a lone pair that isn't bonded, and there's 3 covalent bonds. So each covalent bond gets 1 nitrogen electron, and it also has a fluorine electron, so hence the cross. So don't forget also to fill up the outer shell of the fluorine atoms, because you'll lose the mark if you don't do that. So taking that idea across to boron, again you've got 3 fluorine atoms, but boron is in group 3, so there's only 3 electrons in its outer shell, so no lone pair this time. But the same idea, again, the circles represent boron's electrons and the crosses represent fluorine's electrons. Now, it might seem a little bit strange to have to leave it as 6 electrons, but boron only has 3 electrons to start with, so it's not going to be able to supply any more electrons, so you're stuck with 6 in the outer shell. But the important thing to remember before we finish off is to make sure you have the outer shell electrons in all the atoms in order to get the mark. Okay, thanks for listening. Until next time, see you soon.